Let us talk about distance form of a line. Distance form, or in other words, parametric form. This is a very interesting concept which will make the problem solving very easy in a lot of problems. So while writing the equation of line in distance form of parametric form, let us say we are given two things. One, a point through which this line passes. Secondly, the angle of inclination that it makes with the positive direction of x-axis, or the angle that it makes with the positive direction of x-axis. So if I know the angle, I can easily find the slope, right? If angle of inclination is known, I have got the slope, and one of the points here is given, and I am going to write the equation in parametric form. Okay, so let us consider this coordinate axis. All right, let us say we are going to write the equation for this line where I have got this point as x1 y1. Okay, and this line makes an angle theta with the positive direction of x-axis, right? These two information I've got. Now to write the equation of a line, I need a general point. Let me take a general point here, P, x comma y. You can take this point anywhere on this line, right? Accordingly, this distance will change, and we will find. So this is a general point. You can take it anywhere on this line. Still, the equation will be same. I'll let you know about a parameter, which is, let us say this point is at a distance of r. So if you keep changing this distance r, you will reach at different points on this line, right? There is, if let us say r is a fixed distance in some of the questions, then you can say there will be 2 points at a distance of r units from this fixed point. One, this one, and another on the other side of this point. So let us first of all consider this point and this point only. If I drop the perpendiculars on x-axis and join this by drawing this line parallel to x-axis like this, what can you say about this angle here? This will be corresponding to this angle, so it will also be theta. So this distance here is r cos theta, and this side of this triangle is r sin theta. This is something we know, right, from the basic knowledge of our trigonometry. But in terms of coordinates, what will be this distance? It will be difference of these x coordinates, x minus x1, right? And in terms of y coordinates, what will be this distance here? It will be y minus y1, right? So this r cos theta is equal to x minus x1. So what will be r? R will be x minus x1 divided by cos theta, and from here r sin theta is equal to y minus y1. So what will be r? It will be equal to y minus y1 divided by sin theta, right? So I've got this equation here. This is the equation of a line passing through a point x1 y1 making an angle theta with the positive direction of x-axis in parametric form. So this is the equation that we were looking for, right? Now some of you can take this point P on this side. Let us say, let me take this point P here on this side of this point P comma P is x comma y. Now if you make the triangle once again and calculate everything, now this angle will be theta, right? Forget about this for a moment. So this will be r cos theta, this will be r sin theta. Now what will be r cos theta in terms of coordinates? It will be x1 minus x, x1 minus x. And what will be r sin theta? It will be y1 minus y. Now if you want to write r in terms of y1 minus y, you can write r equal to, or let me write in these terms first, x coordinates first, x1 minus x by cos theta, and here we can write it as y1 minus y by sin theta. This is another equation for the same line, right? The only difference is the change of these signs. Let me explain this change of signs to you. And we should remember that Why did this change occur? That once we took the point, the general point, below the given point, and once we took it above the given point. Now from this, what is r? What is r? R is equal to x minus x1 by cos theta. I am considering these first. So what can you say about my general point x? X will be equal to r cos theta plus x1, or in other terms x1 plus r cos theta. And from these two I can say what will be y? Y will be y1 plus r sin theta. Now look at this. From here, what can you say about x? If I bring this, let me solve these first. X1 minus x will be equal to r cos theta. So what can you say about this x here? So x will be equal to x1 minus r cos theta. In first scenario it was the case, and in this second scenario the case was x1 minus r cos theta. Similarly, y was y1 minus r sin theta. What was the difference in both of these? This was the case when point xy was above x1 y1, right? And in this case it was below x1 y1, right? So now if I want to write a general point at a distance of r units from this point x1 y1, so I can write it like this: x equal to x1 plus minus r cos theta, and y is equal to y1 plus minus r sin theta, because this point can be above the given point or below the given point. Now if you want to write it collectively or in simple terms, you can simply write that x will be equal to x1 plus r cos theta and y will be equal to y1 plus r sin theta, where r is the algebraic distance. Algebraic distance. What I mean is r will decide the sign here, right? If r is above the given point, let us say this is the given point and this is the point which is above this, right? Let us say this is x1 y1 and this is xy. Now this is above this point, so it will be equal to x equal to x1 plus r cos theta. Now in this case r is positive, right? And if this is below this point, then r will be negative. So r itself will take care of the sign of the points. Let r be the algebraic distance. So these two forms, or this parametric form, will take care of the fact that the point is above it or below it. So r is the algebraic distance. R will be positive when the point is above or on the right of the given point, and it will be negative when the point is on the left of the given point. So you can simply, or in simple terms, when you have to consider or assume a point in terms of x1 and r and theta, then what you can do is you can simply consider that point xy as x1 plus r cos theta, comma y1 plus r sin theta. Xy can be simply taken as x1 plus r cos theta, y1 plus r sin theta. Now you don't have to worry about the sign, whether you put plus or minus here, because r that you are taking is the algebraic distance. You take it as positive if you are talking about a point above the given point. You take it as negative if you are talking about a point below the given point. I hope this much is clear to you. Now to make it more clear, let me take one of the questions. Let me take this question here. Give me a moment. Let me write the question. Now see, look at this question. Find the distance of a point 1, 3 from this line, right? But this distance should be measured along a line x minus y plus 1 equal to 0. So if I ask you what is the slope of this line, you will say slope of this line is equal to 1. Why? Because if you can write in slope intercept form, y will be equal to x plus 1 So coefficient of x here is 1. So the slope of this line is 1. And what can you say about tan theta then? Tan theta is equal to 1. Hence, I can say that theta is equal to 45 degrees because theta varies between 180 to 0 to 180 degrees. So theta is equal to 45 when tan theta is equal to 1. Right? So what we are supposed to find is, we are given this line and this point. This point is 1 comma 3, let us say. This point is 1 comma 3, right? And this line is 2x minus 3y plus 9 equal to 0. And we are going to measure a distance along this line, that is x, let us say this is the line, x minus y plus 1 equal to 0. So it has got a slope of 1, so it is inclined at 45 degrees, right, with the positive direction of x-axis. Right. So we want to find this distance here. Now some of the students may think, let us consider this distance to be r. Some of the students may think that I have taken this point below this line. You can take this point above this line also, because in the answer the sign of this r will take care of itself, will take care of this fact. I'll explain you why. Now I have considered this point here and this to be r, right, and the distance is to be measured along this line. So what can we say about the equation of this line? I have been given this point 13 and I have been given the angle of inclination. So I can say that if I take this point to be my general point, so I can take the equation as x minus x1 divided by cos 45 equals y minus y1 divided by sine 45 equal to r. Okay, we were not required to write this equation. I have just written it for the sake of revision. Otherwise you could have simply considered the coordinates of this point as x1 plus r cos 45, right? What is x1? This is 1. So 1 plus r cos 45. What is cos 45? It is 1 by root 2, comma y1 plus r sine 45. What is y1? It is 3. So 3 plus r sine 45, that means r into 1 by root 2. So you can take the coordinates of this point, which is at a distance, we have considered that it is at a distance r from this point, as these coordinates. Now that we know the coordinates of this point, we also know that this point lies on this line 2x minus 3y plus 9. So this point should satisfy this line. Let me put x and y coordinates in this line and satisfy it. 2 into 1 plus r by root 2 minus 3 into 3 plus r by root 2 plus 9 is equal to 0. Right? Now see, if I simplify it further, it will be 2 plus 2r by root 2 minus 9 plus minus 9 minus 3r by root 2, and this is plus 9 equals 0. So this 9 gets cancelled with this 9 here, and this is 2r by root 2, this is 3r by root 2. So I can write it as 2 minus 1r by root 2. 2 minus 3 is minus 1, right? 2 minus r by root 2 is equal to 0. So if I solve it further, I can say that r is equal to 2 root 2, right, which is a positive value of r. So r is equal to 2 root 2 units. This is what we were supposed to find. Now r has come out to be positive, which means that we have considered the correct position of this point, that this point will be below this given line. Why? Because r has come out to be positive. That means this point that we assumed the coordinates of is above this point.